Hi everyone. This video is actually what I would categorize as a preview activity. So I would love it if you would pause for a second and try and work through this on your own. And in fact, I see my own note preview continued all the way up through this part C on the next page, and then come back and watch at any point if you get stuck and get yourself caught up. Okay, so substitution is the integration trick that reverses the chain rule. So remember what our chain rule looks like. It says if you take the derivative of a composite function, you'll get the derivative of the outer function evaluated with the inner function times the derivative of the inner function. So we want to be able to reverse these things and in general find antiderivatives of composite functions. So I want you to hopefully first be going through and trying to take derivatives. So if you want to recheck those, remember e to the 3x, e to a function, e to a power is its own derivative. So we'll get e still evaluated at 3x, and then we multiply by the derivative of 3x, which is 3. The derivative of sine of a function should be cosine of that function times the derivative of that function. So the derivative of 5x plus 1 is 5. The derivative of arctan of a function should be 1 over 1 plus that function squared multiplied by the derivative of that function. So the derivative of 2x is 2. And last but not least, a function to the 4th power. The derivative of that should be 4 times the function cubed multiplied by the derivative of the inner function, which is going to be -7. The derivative of 2 minus 7x is -7. Okay, so now we want to look at what we've done and see if we can work our way backwards. And they're not perfect matches, so you'll have to think about it a little bit. But we want to look at the derivatives we've got. Remember, if we have the derivative, then we know its antiderivative would get us back where we started. So I want to know what I would take the derivative of to get e to the 3x. And I know when I took the derivative of e to the 3x, I got almost the right thing. I got e to the 3x times 3. But I don't want that 3 showing up when I take the derivative. So I'm going to correct for that. So I'm going to call this big G by dividing by 3. So now to check myself, remember you'd always take the derivative. The 1/3 dividing by 3 is the same as multiplying by 1/3. We'll just carry through. The derivative of e to the 3x is e to the 3x times 3. And we get some nice cancellation, and there's our e to the 3x that we were hoping to get. So I think we've got it right. Similarly, cosine 5x plus 1, when we took the derivative of sine 5x plus 1, we got cosine 5x plus 1 times 5. So that's really close. So we'll say, well, sine of 5x plus 1 was pretty darn good. But it's not quite right. I get that extra 5 from the chain rule and I don't like it. So I need to make sure that I have a 1/5 to cancel it out. Okay, so for the 1 over 1 plus 4x squared, again, these are all kind of paired up so you can see a little bit of what we're trying to guess our way out of. We got 2 over 1 plus 4 times x squared when we clear parentheses. When we started with arctan of 2x. That's really close. Okay, catch up on writing. But we don't want the 2 in the numerator, so we're going to have to cancel it out by throwing a 1/2 in there. And very last of all, we want to know what to take the derivative of if we're hoping to end up with 2 minus 7x to the 3rd. And again, we got close to that when our function was 2 minus 7x to the 4th. but we got an extra factor of -28. When we rearrange there, we have a 4 and a -7, and it's all multiplied. So this is really what we've got. So we're going to have to divide by -28. Okay, so sometimes not too bad, right? If it's just a constant that's causing the problem, that's somewhat manageable to deal with. Let's see what I got for you in part C. So in this one, I just want you to try it without the leading up to it example of taking the derivatives. So again, I'm asking myself, and we've even done some of this along our way just as kind of preliminary practice, what do I take the derivative of to get cosine of pi x? So I know to get the cosine, I need to start with a sine. And I'm only going to have the pi x inside when I'm done if I have the pi x inside when I started. So you could check yourself by taking the derivative of whatever you've got so far. The derivative of sine is cosine. Leave pi x alone. And then we chain out the derivative of pi x. So we're close, but we don't want that pi. So we'll do 1 over pi. Ooh, plus c. Pretend like I didn't forget plus c on the last page. Okay, we want to figure out what we would take the derivative of to get 4x plus 7 to the 11. So I know that I'd need a power rule involved. So I probably started with a 4x plus 7 to the 12. If I do a check on that, I'm going to get the 12 times 4x plus 7 to the 11, and I'm also going to chain out a 4. So I did get the 4x plus 7 to the 11, but I also got a 48. I don't want it, so I'm going to divide it out by building my constant this way. Okay, and last one, maybe the trickiest. We start to get into territory where it can be a little dangerous to guess and check your way out, but always good to try it. It's kind of a challenge one. I know that if I want an e to the x squared, that e to the stuff is its own derivative. So I'm going to say, well, maybe I want an e to the x squared to be part of this. When I start checking on that, the derivative of e to the x squared is e to the x squared times the derivative of x squared. So I'm actually really close. I got that x that's sitting out in front. I just have an extra 2 that I need to cancel. So this is kind of what we're going to be trying to do. Our method is not going to be trial and error. So please don't just try and trial and error your way through all of these. I'll want to actually see substitution so that I know you can do this. But that's what we're looking at. Okay, thanks for watching the intro.